It's profoundly exciting to see something that no one has ever seen before.
We now know that solving this problem is doable.
It makes me feel amazing.
This is the start of something big.
The Bertarelli program in translational neuroscience and neuroengineering was founded 10 years ago with the aim of bringing scientists and physicians and engineers together in order to create therapies that would change people's lives. The foundation came to Harvard because we have a 400-year tradition of leadership, especially over the last 50 years in neuroscience. In fact, 5 Nobel laureates in sensory neuroscience have been on the faculty at Harvard. The Bertarelli program has had a tremendous impact on basic science, on translational science, and on engineering for science. The real key to the success is collaboration. Bringing scientists and engineers and physicians to come together on a project to do things that no one of them could do by themselves. So far, the program has funded 15 different collaborative projects, focused especially on sensory disorders, on deafness, blindness, and on pain. The program allows us to fund bold but risky ideas that traditional funding mechanisms wouldn't support. It believes in the best scientists, and it has faith in them to carry that research out. And that's how truly game-changing breakthroughs happen. An example of this is a collaborative project between physicists involved in optics, Dimitri Saltis, and an otolaryngologist focused on patient care, Tina Stankovic.
Hearing loss is the most common sensory deficit across the globe, currently disabling nearly 500 million people. And despite the magnitude of the problem, today we don't have an imaging tool that allows us to see cells inside a living human inner ear and tell people why they're going deaf. The current project that we are working on is the development of a tiny sub-millimeter imaging probe that we can insert into a human inner ear to establish cellular level diagnosis. When we started working on it, most people thought that it was a crazy approach and that it would never work, but we have proven them wrong. The imaging probe has allowed us to demonstrate the feasibility of this approach, and now we have enough preliminary data so that we have been able to secure governmental funding to take this project to the next level. It's really important for the government to invest in this type of technology because hearing loss and tinnitus are the 2 most common disability claims of veterans.
Our project is a great example of what you can achieve when the fear of failure is removed. We started out with some ideas that, we did our best to plan the experiments, but the experiments didn't go the way we expected. However, in doing those experiments, we started to make some observations that we never really set out to make. And at the same time, another group discovered that the synapses of the ear are vulnerable to excessive noises. In the future, we hope that our research will lead to the development of eardrops that could protect the synapses in your ear. This could never have happened without the freedom to fail.
Opioids are very effective at treating pain. One of the problems associated with opioids, of course, is they're highly addictive. They've driven the opioid epidemic, which is a huge burden to society. The Bertarelli Foundation has been instrumental in allowing us to move basic science into the clinic. This has allowed us to gain a fundamental understanding of the different types of pain cells involved in different types of pain: hip pain, skin pain, pain associated with the colon. Our fundamental understanding of the molecular properties of nerve cells involved in different types of pain are now allowing us to collaborate with chemists and pharmacologists to develop new ways of treating specific types of pain, and thereby removing our dependence on the use of opioids. Finally, there's light at the end of the tunnel for this big, big problem.
The research projects supported by the program are so unique that the equipment needed to carry out the experiments hasn't been invented. And so the program also supports a research instrumentation core facility that can invent, design, and fabricate a new generation of instrumentation in close collaboration between the scientists and engineers.
Typically, an engineer would be brought a pretty well-defined problem. You need to build a bridge of a certain size that can bear a certain weight, something like that. But when a biologist comes to an engineer with an idea for a crazy experiment, often it's difficult for us to define exactly what the specifications are. You can go in and speak with the engineers and they can make an instrument for you. Or, if you prefer, they can teach you how to use the machines in the core facility to make that instrument yourself. My lab is interested in how different sensory cues are used to assemble a sense of space in the brain. A common consequence of aging-related decline in the brain is a sense of disorientation. To understand what it means to be disoriented, we have to understand how the brain builds up a picture of its environment under healthy circumstances. And so to make these measurements, we study fruit flies. The instrumentation core facility helped us design realistic virtual reality environments that allows the world to rotate around the fly. And if we understand how that works in a tiny brain, I think we're much closer to understanding how that works in a complex human brain. This kind of funding allows us to get ideas off the ground that would otherwise be impossible.
The Bertarelli Foundation is not just supporting science, it's supporting scientists. It's creating the next generation of investigators who can carry this research into the future. A great example of this is the Bertarelli Fellowship Program that brings 5 students a year from Switzerland to study and work in laboratories of Harvard scientists. Over the past 10 years, more than 40 students have benefited from this program.
It's definitely a big honor to be able to come here. I mean, not everyone is able to come to Harvard and spend an entire year doing great research with great biologists. And I suggest everyone to try and apply and try and come here.
10 years of investment into bold but high-risk ideas by the best scientists has paid off in ways we could only imagine. We've come so far.
This kind of innovative, forward-thinking science takes years. And the Bertarelli Foundation has allowed us to do things that we never thought were possible.
The Bertarelli Foundation is phenomenal because they are eager to find radical ideas that are addressing high-risk, high-gain projects.
I've been doing this for a long time. Now, over the last few years, this is really the first time that I've thought that all of this knowledge that's been created over the last few years is going to be useful for reducing human suffering.
We set out with a vision to change people's lives for the better. And that meant moving half a century of basic neuroscience into the clinic to find therapies for some of the most devastating psychiatric and neurological disorders. Thanks to a decade of support from the Bertarelli Foundation, we can now offer to patients hopes for a cure in ways that we couldn't have even dreamed of.
The establishment 10 years ago of the Bertarelli program in translational neuroscience and neuroengineering was a major milestone for Harvard Medical School. Ernesto had a vision for translational neuroscience powered by the essential collaboration of basic scientists, clinicians, and engineers who would bring together their unique individual expertise to advance new insights and innovative therapeutic approaches that we could never have imagined they would make on their own. Ernesto's vision was prescient. It preceded and has informed the critical development of the Harvard Medical School Therapeutics Initiative, an initiative that I have made a major priority as dean. Now, the investigations and insights into the auditory and the other sensory systems made possible by the Bertarelli family have advanced us to the frontiers of brain science and opened new avenues of inquiry and breakthroughs we could have never imagined. So as a clinician and a scientist and as dean, and on behalf of Harvard Medical School, I want to thank you.